In the previous video, we looked at question number 1 to 6 from this January 2023 Pure 2 paper, Pure Math 2 paper. So in this video, we are going to start from question number 7. This is from sequences and series. A geometric sequence has third term 20. You can write the third term as AR square. And the fifth term, AR power 4, is 12.8. Remember the formula for nth term, AR power n minus 1. So for third term it's square, fifth term it's power 4. Show that R is 0.2. Divide these two. So you will get AR power 4 divided by AR square is 12.8 divided by 20. R power 4 divided by R square is just R power 4 minus 2 is this. So R is square root of this number. Square root of 12.8 divided by 20. 0.8. It's just a one mark question. And they want you to find the value of A. A is the first term, they say. Sub in R back into any one of the equation. So A is basically 20 over R square. 20 over R square. 31.25, that's A. A is 31.25. So that's the value of A and R. Let's move on to part B of this question. Find given that the sum of n terms is greater than 156. Sn is given as greater than 156. Find the smallest possible value of n. Okay, the value of R is basically less than 1. So we are going to use the corresponding formula. A 1 minus R power n divided by 1 minus R is given as greater than 156. Sub in the value of A and R here. The A value we got from the previous part is this, times 1 minus 0.8 power n divided by 1 minus 0.8 is greater than 156. 1 minus 0.8 is basically 0.2. So 0.2, bring it here, it becomes multiplication. 31.25 becomes a division. So you will get 1 minus 0.8 power n is greater than 156 times 0.2 divided by 31.25. 156 times 0.2 divided by 31.25. We'll get this value, which is 0.9984. So instead of this, I'm going to write it as 0.9984. 0.9984. Now you put this number here, this number here. So 1 minus 0.9984 is basically 0.0016. So you will get 0.0016 is greater than 0.8 power n, and we need to take logarithm both sides to solve this. So before taking, I'm going to take the logarithm both sides. Log 0.8 power n is less than log 0.0016. By applying laws of logarithm, we can write the power in front. N log 0.8 is less than log 0.0016. Now we are going to divide by log 0.8, but in an inequality, before you multiply or divide, you need to know whether it's positive or negative. So I'm going to find the value of log 0.8, which is a negative number. So when you divide by a negative number, you need to flip the sign. Log 0.0016 divided by log 0.8. Find the value of it. Log 0.0016 divided by log 0.8. get 28 point something, n is greater than 28 point, the decimal number can be anything. So the next integer is 29. That's the answer. Let's move on to question number 8, solving trigonometric equation. This is a harder trigonometric equation. In this form is called harder trigonometric equation. Since the x is multiplied by 3 here, you need to multiply the limits by 3. So it's going to be minus 3 pi over 2 is less than 3x is less than 3 pi. I'm not going to add 0.1. The method I'm teaching, I'm not going to add 0.1. I'll just multiply by 3. But when I use the CAS diagram, I take one extra solution actually. So I'll put the equation here. So I have the equation here, and the new modified limit is minus 3 pi over 2 is less than 3x is less than 3 pi. So first we need to find the principal value. How do we do that? Sine 3x plus 0.1 is, bring the 2 to the other side, minus 2 divide by 5, minus 2 by 5. So 3x plus 0.1 is, when you find sine inverse, just take the positive value. That's a method I'm teaching. Just take the positive value and find the sine inverse of it. That's the principal value. Use your calculator in radian mode. Number 4 for radian mode. Sine inverse of 2 over 5 is 0. Blah blah blah. We need all the decimals. We cannot round the decimal. Though I'm going to write it as 0.41 dot 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 dot. I'm going to immediately store the value as a. Store it as a. Now I'm going to use CAS diagram, AESTC diagram. First, the negative limit is 0 to 3 pi over 2. This is minus pi over 2, minus 2 pi over 2, minus 3 pi over 2, which covers 3 quadrants. You need to look for a quadrant where sine theta is negative, which is in here and here. So the corresponding angle is minus theta minus pi plus theta. Theta is the principal value. So 3x plus 0.1 is equal to minus theta, comma, minus pi plus theta. We got 2 solutions for the negative limit. Now let's look at the positive limit now. 0 to 3 pi. First find 0 to 2 pi. It covers 4 quadrants. Sine will be negative here and here. This will be pi plus theta, 2 pi minus theta. So pi plus the principal value, 2 pi minus the principal value. And then from 2 pi to 3 pi, we are at 2 pi now. From 2 pi to 3 pi, there are 2 quadrants, and sine will not be negative in any one of these quadrants, A and S. But since we are not adding plus 1 to the limit, you need to go out of the limit and take the next solution, which is here in this quadrant where the angle is 3 pi plus theta. So 3 pi plus theta. Now we have 5 solutions now. What we need to do now, subtract 0.1 from each of these 5 values and divide by 3. That's what I'm going to do one by one. And then when I get 5 values, I need to compare the values with the original limit, and whichever value lie inside this limit, I take it. If it's outside the range, outside the limit, leave it, ignore it. So the actual limit is minus pi over 2 to pi. So basically minus pi over 2 is minus pi over 2 is minus 1.5. So this is the actual limit, minus 1.5 etc. to pi 3.14 etc. So I'm going to calculate it one by one. The first value is this one is, I stored the value as a actually, times negative 1. So minus theta minus 0.1 divided by 3. Definitely it's inside the limit. So that's minus 0.17. They want the answer to 2 decimal place. So minus 0.17, that's the first solution. Now for the second one, minus pi plus theta, principal value which is stored as A, minus 0.1, everything divided by 3. Negative 0.94, negative 0.94 corresponding to this. This negative 0.9 also within this limit. Two solutions. First one is negative 0.17, negative 0.94. Let's move on to the next one now. This one. Pi plus theta minus 0.1 divided by 3. 1.15. So 1.15 also within the limit. Now the next one, 2 pi minus theta. 2 pi minus theta minus 0.1. You need to minus 0.1 and divide by 3 for every values. 1.92 is also within this limit. 1.92. Let's look at the last one, the one we have taken extra. Sometimes it will fall within the limit, you need to double check. 3 pi plus theta minus 0.1 divided by 3. 3.24, which is outside the range, so just ignore it. So you got 4 solutions already. That's all. Part B of the question, AA of this question, the same question. This is also from trigonometry. They want you to solve this equation where you have sine theta, cos theta and tan theta. But if you want to solve a trigonometric equation, you need to have a single trigonometric function. You cannot have more than a single one trigonometric function. So I'm going to replace tan by sine over cos times sine is equal to 5 plus cos theta. So multiply throughout by cos theta, I will get 2 sine square theta is equal to 5 cos theta plus cos square theta. In order to change the whole equation in terms of a single trigonometric function, I am going to replace sine square by 1 minus cos square. So it's going to be 2 times 1 minus cos square minus 5 cos theta minus cos square is equal to 0. Open the bracket and simplify the like terms. You will get minus 2 cos square minus 3 cos square theta minus 5 cos theta plus 2 is 0, or you can write it as 3 cos square theta plus 5 cos theta minus 2 is 0. I'm going to solve this quadratic equation. 3 5 minus 2, 3 5 minus 2, I got 1 over 3 and negative 2. So cos theta is negative 2, cos theta is 1 over 3. We can write it as a factor. Cos theta plus 2, 3 cos theta minus 1 is 0. We got two equations. Range of cos theta is minus 1 to 1. So for this one, no solution. So we just need to solve cos theta is equal to 1 by 3 in this interval. That's a simple trigonometric equation. Take the equation cos theta is equal to 1 over 3. The limit is 0 to 360 degree. Find cos inverse of 1 over 3. That's a principal value. You need to use your calculator in degree mode. Cos inverse of 1 over 3 is 70.52 and all. They want the answer to 1 decimal place, so 70.5 degree. Use the cast diagram. The limit is 0 to 360. Cos will be positive here and here. So theta and 360 minus theta. So the solution is theta, which is the principal value, and 360 minus theta. which is 289.5 degree. 289.5 degree, 70.5 degree. We got two solutions already. Let's move on to question number 9 now. Question number 9, part A. The figure 3, there is a figure given. Figure 3 shows a curve with y is equal to, this is a curve, y is equal to x square minus 4x plus 5, and the line L, y is equal to 2. So this point is basically 2. That means every point has y coordinate 2. The curve C intersects y axis at D. Find the coordinates of D. It's very easy. In this curve, replace x by 0. So this becomes 0, this becomes 0, y is 5. So the D is 0, 5. It's just a 1 mark question. Now find the x coordinate of E and F. Let's look at the diagram. It's a 2 mark question. We need to find the x coordinate of E and F. So we need to solve the equation y is equal to x square minus 4x plus 5, and the equation of the straight line y is equal to 2. So when you combine them, x square minus 4x plus 5 is equal to 2. Bring the 2 this side, plus 3 is 0, which is x minus 3 times x minus 1 is 0, x is equal to 1, 3. They just want you to find the x coordinate of E, and x coordinate of E is 1, x coordinate of F is 3. That's all. Now let's look at part C of this question. In the figure, there is region R1 and R2. I'm going to put the figure here. There is R1 and R2. The area of R1 divided by area of R2 is equal to K. They want you to use integration to find the exact value of K. Okay. Now, if you just look at the diagram, we know this point is 2, this point is 5. We calculated it in part A. And this is 1, 2. This point is 3, 2. To find R1, you integrate the curve from 1 to 2, 0 to 2. When you integrate the curve from 0 to 2, you will get this whole area. And then you can just subtract this little area of this rectangle. This point is 1. So the area of the rectangle is 1 times 2. You can subtract 2. So you will get area of R1. So I'm going to find area of R1 now. R1 is, I'm going to integrate the curve from 0 to 1. The curve is basically x square minus 4x plus 5 dx. And then subtract the little rectangle. The area of the rectangle is 2. So when I integrate it, I will get x cubed by 3 minus 4x square by 2 becomes 2x square plus 5x 0 to 1 minus 2. When I sub in the limit, 1 over 3 minus 2 plus 5. Lower limit is 0, everything becomes 0. Then minus 2 again. So it's basically 1 over 3 minus 4 plus 5. So the area of R1 is 4 over 3. Now we need to find R2. The easiest way to find R2, we know this point 3, 2. So treat this as a triangle. The height of the triangle is 5 minus 2, 3. The base is the x coordinate of the point 3. So you can find the area R2 is equal to half base times height, which is 9 over 2. But if you look at closely, R2 is not this whole triangle actually. You need to take the triangle and subtract this R1. That's basically R2. So R2 is this minus R1. So minus 4 over 3. 9 over 2 minus 4 over 3. 9 over 2 minus 4 over 3 is 19 over 6. 19 over 6. So it says area of R1 divided by R2 is equal to K. So R1 divided by R2 is equal to K. Just divide it, you will get the answer. R1 is 4 over 3 divided by R2 is 19 over 6. Or you can put it as a reciprocal of 19 over 6 and multiply. So the value of K is 8 over 19. That's all. Question number 10 now. A student was asked to prove by exhaustion that if n is an integer, 2n square plus n plus 1 is not divisible by 3. Okay. So usually, let's say this is not given. They want you to prove this using proof by exhaustion. Usually for proof by exhaustion, you will be given finite numbers. But here you have infinite numbers. N is an integer. So you need to divide them into certain categories. So since we are trying to prove it's not divisible by 3, it's wise to divide them into these 3 categories. 3k, 3k plus 1 and 3k plus 2. And then sub in and prove it's not divisible by 3. The expression is not divisible by 3. But a student's work is given here, and the student has already finished the proof for 3k. And it's proved it's not divisible by 3. They want you to complete the proof. So you need to do it for 3k plus 1 and 3k plus 2 now. So let's take n is equal to 3k plus 1. N is equal to 3k plus 2. And take the expression 2n square plus n plus 1 is, replace n by 3k plus 1. Plus 1, which is 9k square, I open the bracket also, plus 2ab is 6k, which is 12k, plus 1 multiplied by 2, plus 3k plus 2. So if you take 3 as a common factor, 6k square plus 15k is 5k, 2 plus 2 is 4, right? I'm going to write 4 as 3 plus 1 and take 3 as a common factor. Hope you understand this step. Or I can write one more step here. Write it as 18k square plus 15k plus 4. 2 plus 2 is 4. Instead of 4, I'm going to write it as 3 plus 1. So that I can take 3 as a common factor from the first 3 terms. So it's in the form 3 times something plus 1 is not divisible by 4. Is not divisible by 3. We need to do the same thing for 3k plus 2. 2n square plus n plus 1 is 2 times 3k plus 2 whole square plus 3k plus 2 plus 2. Open the bracket, square and open the bracket, 9k square, which is 18k square. 4 3s are 12k is 24k, plus 2 square is 4, 4 2s are 8, plus 3k plus 4. When you simplify, you will get 18k square plus 27k. These two are 11. I'm going to write it as 9 plus 2. So I can take 3 as a common factor from the first 3 terms, 6k square plus 9k plus 3 plus 2. Not divisible by 3, write again. Therefore, you need to write the original statement. 2n square plus n plus 1 is not divisible by 3 for all n belongs to z. Z is set of all integers. Just copy the original statement from the question and write. Therefore, you need to write this whole thing. That's all. It's proved by exhaustion.